Okay, hello, welcome to my channel. Now in this video, we're going to look at derivative of some trigonometric functions. Good. So we have the functions and then we have their respective derivatives, alright? So this is sine of x. So we have sine of an angle x, then the derivative of that is just going to be cosine of x, alright? And again, the derivative of cosine will be sine of x, but here we will have a negative sign. So you know that whenever you're differentiating cosine of x, you're going to put negative sign, but when you're differentiating sign, you do not put a negative with the cosine. Good. We look at the derivative of tangent of x is going to be secant squared x, where secant x is the same thing as 1 over cosine, alright? So we have secant x, you can take that to be the reciprocal of cosine of x. Good. And then we have function, trigonometric function, such as the cotangent of x, and the derivative of that is negative cosecant squared x. And lastly, when we have cosecant squared x, well, cosecant is the reciprocal of sine x, right? Cotangent here is the reciprocal of tangent of x. So when we differentiate cosecant x, we enter with negative cosecant x times cotangent of x. Good. All right. Now in this video, I will look at this function and look at their derivatives, all right? I'm going to show you how to get the derivative of tangent of x, which is secant of squared x, all right? But we are going to be making use of this tool. The tool here is going to be the quotient rule. And it tells us that if y is a function, okay, as a fraction, written as a fraction, that is u over v, where u and v are functions of x, then the derivative of y with respect to x is going to be, well, you will keep the denominator and then differentiate the numerator, minus, you keep the numerator, which is u, and then differentiate the denominator, which is v, then you divide everybody by the denominator squared, that is v squared. Okay, so let's apply that to the third function, which is the tangent, and see what we've got. So if you have y to be tangent of x, right? Okay, so you want to differentiate that function with respect to x. So I put it down here, the y, the x, to be what? Well, first of all, tangent of x is the same thing as sine over cosine of x, alright? So I can replace this with sine x over the cosine of x. That is just by trigonometric identities. But we have tangent x is the same thing as sine over cosine, and that will help us to make use of the quotient rule, right? Good. And the quotient rule tells us if y is of two form u over v, right? So we have sine x over cosine x. If I make the sine x to be u and make the cosine of x to be v, then we can apply the quotient rule appropriately, all right? Good. The rule tells us that when we want to differentiate y with respect to x, that is the derivative of y with respect to x, we are going to keep the v first and differentiate the u. So we keep the v, where the v is just cosine of x, we keep the cosine of x and then differentiate the u, all right? So we're going to multiply it with the derivative of the u. Now, the u here is sine x. The derivative of sine x is cosine of x, all right? So in place of the derivative of sine x, I'm going to put down cosine of x. Good. Next thing we have to do in here is to subtract it with, so you put it here minus. We put down the u, all right? Here we were putting down, keeping v and differentiating u. Here we are keeping u and differentiating v. So we keep the u, where the u is just sine x, right? Remember the minus. We keep the u, where u is sine x. And then we multiply it with, we differentiate v. According to this, we differentiate v. So the v there is cosine x, right? And then the derivative of cosine of x is going to give us negative sine x. So you put down the negative sine x. Good. And lastly, we will need to square this denominator, right? And put it here as the denominator of this derivative of the function. So we see the denominator is this cosine x. So we need to square that. Well, when you square cosine x, you enter with cosine square x, right? Just like saying cosine x squared is the same thing as writing it as cosine squared x. Good. And now this is what we've got. We can simplify things in the numerator a little bit. We're going to enter with cosine x times cosine x. That is going to be cosine squared x, right? Just by multiplying two cosine together. Now, negative sine x times negative sine x, that will become positive sine squared x, all right? All right, good. And then we divide that with cosine squared of x. Okay, this is what we've got. In the numerator, we have the sum of two perfect squares. Well, from trig identities, when we have cosine of squared of an angle plus sine squared of that same angle, the result of that sum is going to be 1, all right? Okay, good. And then the denominator just enter with cosine squared x. Great. Now, very wonderful. We have 1 over cosine squared x. Well, this right here, okay, 1 over cosine squared x is the same thing as secant squared of x. Remember, I told you that 1 over cosine, okay, is the same thing as secant, right? Secant of x. So if you square this, that is, if you square this, okay, you also square this 1, right? Good. So I can rewrite this as 1 squared over this squared, which gives us secant squared x. So that tells us that the derivative of tangent of x is secant squared x, which is just what we have here. Okay, all right. Let's go over and check and solve the derivative of secant squared x and see what we have.